we've now seen a bunch of different string examples between doing examples together on BlueJ and also doing examples on CodingBat. What we're going to do today is 2 more advanced string examples. So in this video, we're going to do the first one. Let's create a new class. We're going to make this a console program, and I'm going to call this the LetterCounter. And what's going to be the goal here is we're going to count up the number of occurrences of the letter A in a string. So let's do this. Let's say string, I don't know, str equals read line, enter a string. Then let's do int num equals count letter, str, and we're looking for the letter A. And then let's print line str has num A's in it. Now, the count letter method is not built into Java, so we're going to have to write it. So let's do the method signature for count letter here. Remember, it starts with public. What is the return type of count letter? It clearly looks like it should be giving me back an int. So let's do int count letter. And how many parameters does it take? It looks like 2, and I think both of them are strings. So let's do string str, I can call that the same thing if I want to, and string letter. So what am I trying to do? I'm trying to count up the number of times letter, which we know is A here, happens in str. Let's say I'm trying to do this with my name, which is Kayla Holman. How many letter A's are in my name? Well, there's actually 3. There's 1 here, 1 here, and 1 here. How can I think about the idea of counting letter A's or counting any number of letters that are in my name? Well, here's my string methods. And again, we're trying to use this small subset of methods to be able to do this larger task. I know I'm going to be doing something over and over again in here, right? I need to count up multiple letter A's. There's actually 2 different ways I can think about solving this problem. And we're going to code both of them together just to see the difference between the 2. There's 2 pretty common ways to solve a problem like this. The first is, let's look through this string letter by letter. And when I see an individual letter, I'm going to check, is this letter an A? I'm going to have some variable keeping track of how many I've seen. And when I see another A, that variable should actually increase by 1. So since I'm going to be looking at every single letter, I actually know exactly how many letters are in my string, right? Which means that what I'm repeating over and over again is this process of checking one individual letter to see if it's an A, and I know exactly how many times I'm going to do that, so I'm going to use a for loop. Let's start, though, by, I know I'm going to be kind of counting something, so let's make a variable. Let's say int counter equals 0. And then, like I said, I'm going to do a for loop that kind of loops through all of the letters in my string. So let's do for int I equals 0. I is less than, how do I figure out how many letters are in my string? Isn't it actually the length of the string? So let's do str.length I++. Now, what is I keeping track of is actually which letter I'm looking at right now. So I starts at 0, which would be this capital K here. Then when I is 1, it's actually this A here. But the question is, how do I actually grab that individual letter? Well, I have to use substring. So let's do this. String letter in str equals str.substring. I can't just put I here, right? I have to do a start and an end. To grab the first letter, we know it's 0 to 1. To grab the second, it's 1 to 2, 2 to 3, and so on. So if I'm using I for this, to grab the ith letter, it should actually be I to I plus 1. If we think about the way that that works, when I is 0, I'm getting the substring from 0 to 1. That's the first letter. When I is 1, I'm getting the substring from 1 to 2. That's the second letter. And you can kind of see how as I increases, eventually this will be every single letter in the string that I'm looking at individually. Now, what do I want to check about this letter? I want to check to see if it's the same as the letter I'm looking for. So let's do if. And how do I check that two strings are the same? I have to use dot equals, which is this one here. So let's do if letter in str dot equals letter. Then what do I want to do? Well, my counter should go up by 1. Let's do counter plus plus. We learned the other day that that's what makes a variable increase by 1. I don't think I need an else here because the else is kind of just move on with your life, go to the next letter, which is what my for loop does. I always have to remember at the very end, I have the word or the type int here, which means I need to return an int. So let's do return counter. And let's try this. Let's compile. And let's actually run the letter counter. And I can run it with Kayla Holman. And it does say that I've got 3 A's in there. Let's go. I think that's what I wanted it to say for this to work. Now, I mentioned that there was another way that we can actually do this. The other way to think about this, instead of checking each individual letter, is actually to think in the way that I'll call the chopping strategy. Instead of looking at every individual letter, we're going to find where the first occurrence of the letter is. We can actually do that with index of. If I do str.index of A with Kayla Holman, it's going to tell me 1. That's where the first A is. I've found an A. What I'm going to do is I'm going to chop off everything before that A and then keep looking for an A in the rest. I'll find this one. I'm going to chop off everything before that and keep looking for an A in the rest. And I'm going to do this until there's no more A's to find. Now, I used a for loop for my first strategy because this was the idea of what am I repeating is looking at each letter to check if it's an A, and I knew how many letters there were. What am I repeating in this one is find the letter, chop it off, and increase the variable by 1. I don't know how many times that process is going to happen because if I did, I would actually know the answer to how many letters are in that string. So instead of a for loop, this one's actually going to work with a while loop. Let's do public int. I'm going to call this count letter chopping. This is the chopping strategy. And it still takes a string str and a string letter. So how does this work? Well, we're still counting something up. So I'm still going to have int, let's call it chops equals 0. This is how many times I've kind of chopped into the string. When am I done chopping is actually when there's no more letter A's left in the string. So how can I check that using my methods here? Well, we know, again, like I said before, this is going to be a while loop. And what I'm looking for is I'm going to keep doing this process while there's still an occurrence of letter in my string. I can check if letter is in my string by using index of. If it's not in there, won't index of actually give me -1? So I'm going to type while str.index of letter is greater than -1. This is a fancy way of saying the English sentence while there is still an occurrence of letter in my string, right? If it was -1, it means it's not there. Let's do this. Let's say int index equals str.index of letter. Let's find where it is. Let's chop it off. And like I said, if what I'm looking for, I'm searching in Kayla Holman, the first index would be 1. Don't I want to make str be kind of 2 to the end? So I want to chop off everything that happens at that index and before. So let's do this. str equals str.substring, because I'm grabbing part of the string. Index plus 1 would let me skip over the letter that I've found. And then what should happen is the number of times I've chopped should go up by 1. So I'm going to do chops plus plus. At the very end of this, I'm going to return the number of chops I made. The nice thing about this method is I don't actually really need an if statement here like I did before. Both of these ways work and will complete the exact same task. It's just slightly different ways of thinking about how to do it. So just to prove to you that that's the case, let's change this to count letter chopping. And I'm going to run this again. And there we go. Let's enter a string, Kayla Holman. And it tells me it has 3 A's in it still. So it looks like the chopping method does work. Now, there's one thing that I don't love about this program right now, which feels a little contrived, but it's been annoying me since we actually started doing some of these string programs, which is sometimes I want the ability to actually try a bunch of different things in quick succession. If I actually wanted to enter a new string and test the letter counter again, I'd have to close out of this and rerun it to enter in, like, I don't know, chicken nugget, which actually has no letter A's in it. And it's a little bit irritating that I can't just kind of enter and enter and enter. So let's say I actually wanted to redo this process over and over again. Well, what could I do? In my run method, I could type while true and actually put all of the code inside here. Now, won't this actually happen an infinite amount of times? So if I compile this and I run the letter counter, it's going to actually keep asking me over and over again, enter a string, I can do Kayla, it has 2 A's, enter a string, I can do banana, has 3 A's, and I can kind of keep going. Now, what's the downside of this is that really I don't actually want to repeat this forever. I kind of want to repeat it until I decide that I'm done. So it would be a little better if the program actually asked me if I want to do it again. So let's do this. I'm going to add a few lines to make this happen. At the top, let's say string response equals yes. Oops, in quotations, yes. And in here, let's make it, after I do this print line, say response equals read line. Do you want to go again? So now it's asking me and kind of actively reading a response. Now instead of while true here, what do I want to do? Let's make this while my response dot equals yes. And let's try to run this. Let's compile, and I'm going to run it. And let's enter a string. And I'm going to enter in Kayla. Yay, it has 2 A's. Do you want to go again? Yes. And I'm going to enter in banana, and it's got 3 A's. Do you want to go again? Let's type yes. And weirdly, it actually quit out. Why is this the case? Remember, strings are case sensitive, which means all lowercase yes is actually not the same as capital Y yes, which is a little bit annoying. Let's actually make it so that I force my response to be lowercase. This is a new string method that we've actually never seen before, but it's not too crazy. Let's do response equals response dot to lowercase. And let's compile this and run it. And let's enter a string, Kayla, and it has 2 A's. And now I can type all caps yes, and it still works. And I can do banana and yes. But I have one other issue now. What if I type, yeah, I do want to go again? Now it actually quits, even though what I've given is an affirmative. Let me change this one more time. Now the lowercase isn't the problem. It's the problem that I'm just looking for the exact letters Y-E-S. So let's actually, I'm going to change one little thing here, which is this. What have I changed now? Well, whatever the response is, I'm grabbing the very first letter of it and then checking to see if that first letter is actually a Y. Am I allowed to chain these dots together like I have? Yeah, I totally am. If you think about it, what type is response? Response is a string. Can I do dot substring on a string? Yeah, I totally can. What type is response dot substring? That's also a string. So can I do some string dot equals? Yeah, I totally can. And now if you compile this and run it, I can do Kayla. Yeah, I want to go again. I can do banana and Y, and then I can do, I don't know, water bottle. And I can type yellow and it'll go again because I can actually now do anything that starts with a letter Y. Phone, and no, I don't want to go again, and it quits out. Let's make this even a little bit better. Right now, this actually only works with the letter A. But I didn't call this the A counter, I called it the letter counter. So instead of assuming that what I want to search for is the letter A, shouldn't I actually make this program ask what letter I want to look for? So let's do this. Let's say string letter equals read line, enter a letter. And now for being really good about this, hypothetically, it shouldn't matter whether I enter lowercase or uppercase for either the string itself or the letter. It should still count the letters as being part of the count. So let's do this. Let's say str equals str dot to lower case, and letter equals letter dot to lower case. Just to make it so that if I'm searching for K and I enter capital K, Kayla, it should still count it, right? Now that I've entered in the letter, I shouldn't just assume that it's A, I need to put letter here. And then same thing here, I shouldn't say that it has this number of A's in it. It should have that number of whatever the letter is. So let's change this a little bit. Let's make this, get rid of the A, quotes here to keep a space, plus letter, plus quotations. And let's see this now. So let's take a look here. If I run my letter counter, if I enter in Amanda and I'm looking for A, it does count that first A in it. And I can do, yes, I want to go again, and I can enter in textbook. And I'm looking for the letter O, and it does actually search for letter O's. And we've kind of made this now so I can search for any letter. Now there's one weird thing that I can do though. Let's do Sally sells seashells by the seashore. And weirdly I can type in C here and it tells me that there's 2 C's in this. And you might say, hey, that's kind of a feature, it's kind of fun, but it's a little weird that it said enter a letter and I was able to enter in something that was multiple letters. So let's actually change this. When the person enters in a letter, how do I know a letter is a letter? Well, the length of that letter should be 1. So let's check and make sure and actually force the person using this to choose again if they chose something or typed in something that was longer than 1. Let's do if letter dot length is greater than 1. Let's say letter equals read line, enter a letter. We're just going to force you to do it again. Great. Let's compile this and let's run it. And let's do, I don't know, banana. And I'm looking for NA, and it's like, okay, screw you, you have to enter in a letter. And let's say I'm actually that jerk who's like, no, haha, I'm going to try this again, and actually doing it again will work. That's because an if statement, how many times will it check, is just once. And what do I really want to do is I want to force this person to keep going until they actually give me a letter that's length 1. So instead of if, let's change this to while. And now I'm going to close out of this and run it again. And now it doesn't matter how many times they do it. It will keep asking until I actually do give a letter. It will keep asking until I do give a letter to look for, and then it will finally actually tell me. So we've blown out this program into much larger than it was before. But we've been able to kind of take a look at some instances where we may want to use while loops to do something a little more interesting with our program. The idea of asking again and kind of forcing certain options like typing in a letter where the length is greater than 1.